Next up for this video, I will talk about what factors roller coaster design affect energy transformation and efficiency. To help you understand more, we will be using a roller coaster model I made for my physics project as demonstration. Now, let's imagine this marble as a roller coaster car. My design had a big initial hill to maximize potential energy at the start. As the coaster moved, I noticed that sharp turns and loops added excitement, but with enough height and energy, the roller coaster successfully passed through the loop with ease. But first, what does the marble stop at all in the first place? In our paper roller coaster, some energy is lost due to friction where the marble rubs against the track, creating heat, and also sound where tiny vibrations and noise absorb energy. This means that the goal is to design the track to minimize these losses while keeping the marble moving smoothly. In my design, there are some strengths and also weaknesses that I'd like to point out. Firstly, the tall starting point provided the marble with substantial potential energy, allowing it to maintain motion through loops and curves. Secondly, the marble consistently passed through the loop, indicating that enough kinetic energy was retained during the track's transitions. As for my weaknesses, in some cases, the marble would fly off the track, which suggests inefficiencies in the alignment or design of curves. By the end of the track, approximately 96% of the initial energy was lost, mainly due to friction, sound, and other inefficiencies in the track design. The marble retained only about 4% of its initial energy as kinetic energy. Now, the improvements I could make to change my paper roller coaster design to enhance its energy efficiencies are using additional support at sharp curves and loops to keep the marble from flying off the track, and also a smoother surface which reduces energy loss to heat, allowing the marble to maintain speed throughout the track. In conclusion, my design worked well overall. The coaster conserved energy as it whooshed through the loops and turns, but not all energy stayed in the system. Friction with the track and sound caused some energy loss by the end, which also, in some cases, the marble would even fly off the track. My role in this project was designing and constructing the paper roller coaster, cutting the paper material for use, calculating potential and kinetic energy, and analyzing energy transformations. This project allowed me to apply physics concepts to a real-world scenario and fostered critical thinking about how to optimize systems for energy efficiency. Reflecting on the experience, I learned the importance of designing, engineering, and how even minor adjustments can significantly improve performance.